Welcome everyone to the second part of this subject, where I will introduce some information about the ICT systems. My name is László Kajdocsi, and you can find some details about me on this slide. In the first chapter, I will talk about the basics of information technology. Let's begin with some term explanations. What does the word information mean? It stands for a new knowledge which comes as a result of an acquisition process. This process can be, for example, reading, learning, watching, and so on. The matter of the gained knowledge is to help people to fulfill their everyday tasks. The next term is communication. Communication is a tool that helps in advertising of information to publicity. Our last word is technology. Technology is the application of scientific knowledge for practical purposes, especially in industry. Technology enables the design of devices that simplify people's everyday life. Let's see the historical eras of information and communication technology. We should compare four main eras in the history of ICT. There are pre-mechanical, mechanical, electromechanical, and electronic eras. The first age was the so-called pre-mechanical era, where cavemen drew rock carvings or communicated by shouting. Later, in ancient civilizations, people started to introduce alphabets and numbers. The first fully phonemic script, the Phoenician alphabet, is considered to be the first alphabet and is the ancestor of most modern alphabets, including Arabic, Cyrillic, Greek, Hebrew, or Latin. The Egyptians invented the first ciphered numeral system, and the Greeks followed by mapping their counting numbers onto Ionian and Doric alphabets. Roman numerals, a system that used combinations of letters from the Roman alphabet, remained dominant in Europe until the spread of the superior Hindu-Arabic numeral system. And this system remains the most common system for representing numbers in the world today. The first paper in the history was called papyrus and made by ancient Egyptians. And one of the most famous inventions of the pre-mechanical age was the abacus, which exact origin is unknown, but it appeared in the ancient Mesopotamia, Egypt, Persia, Greece, or Rome. The second age was the mechanical one that lasted about 400 years from the 1450 until 1840. Main inventions from this era are the slide rule, the Pascaline, the difference engine, and so on. The electromechanical age can be defined as the time between 1840 and 1940. These are the beginnings of telecommunication. The telegraph was created in the early of 19th century. Morse code was created by Samuel Morse in 1835. The telephone was created by Alexander Graham Bell in 1876. The first radio was developed by Guglielmo Marconi in 1894. All of these were extremely crucial emerging technologies that led to big advances in the information technology. The first large-scale automatic digital computer in the United States was the Mark I, created by Harvard University around 1940s. It was programmed using punch cards. The electronic age is what we currently live in. The ENIAC was the first high-speed digital computer capable of being reprogrammed to solve a full range of computing problems. There are four main sections of digital computing. The first was the age of vacuum tubes and punch cards, like the ENIAC and Mark I. Rotating magnetic drums were used for internal storage. The second generation replaced vacuum tubes with transistors, punch cards were replaced with magnetic tape, and rotating magnetic drums were replaced by magnetic cores for internal storage. Also during this time, high-level programming languages were created, such as Fortran and COBOL. The third generation replaced transistors with integrated circuits. Magnetic tape was used throughout all computers, and magnetic core turned into a metal oxide semiconductors. An actual operating system showed up around this time along with the advanced programming language BASIC. The fourth and latest generation brought in CPUs, which contained memory, logic, and control circuits, all on a single chip. The personal computer was also developed, the Apple II. Today, we live in an age where we talk about smartphones and other smart devices, smart homes, smart cities, e-commerce, e-learning, e-healthcare, e-governance, Internet of Things, augmented reality, virtual reality, 3D internet, and others. As next step, in order to understand the basics of information technology, you need to learn the difference between data and information. Data is raw and unorganized facts that is gained from an acquisition process and useless until it is organized, while information is processed and organized data which has meaningful value for its user. In digital space, there are few types of data that can be processed and stored by a computer. These are numeric, text, image, voice, and videos. The functional units are responsible for proper operation of computers. These main units are CPU, which is the central processing unit. The CPU consists of two parts that are the arithmetic logic unit and the control unit. The CPU communicates with the memory, which helps in storing data. Computers also need input and output interfaces in order to interact with the outworld. An input hardware can be a mouse, a keyboard, touchpad, touchscreen, scanner, microphone, joystick, drawing table, different code readers, and others. An output hardware can be monitor, printer, plotter, projector, and other screens. In order to process data, we need to follow a workflow which consists of the following steps. Our first step is the acquisition, where we gain the needed data. Next step is the preparation, which is a process that prepares data for digitalization. After we get the previously prepared data, the next step is the input into a digital system. After input, we are able to process the digitalized data. Finally, we can utilize newly received information and store them for later use. Let's see the storage types. The first one is primary storage. This type is the fastest among each other. Processor registers and cache memory belongs to primary storage. The second type is secondary storage. This type is slower than the primary one, however, still fast enough. Mainly, hard disk drive, solid-state drive, flash memory, and optical memory belong to this category. And the last one is the so-called nearline storage, which has got its name from the near online phrase. Nearline storage is not immediately available, but can be made online quickly without human intervention. The next crucial criteria about computers is the Neumann's architecture. John von Neumann was a scientist with Hungarian roots who worked in the USA. He laid down 6 concepts that establish the basics of computers. Today's computers are still based on his architecture. First of his concept is that a computer has to be fully electronic device. Furthermore, it performs commands sequentially. Computer also has to use binary scale. It needs to use memory as well. And it utilizes the stored program concept. Finally, according to von Neumann, a computer needs to be used for universal tasks. If you go back few slides where we discussed the functional units of PCs, then you can realize that this architecture is based on Neumann's concepts. Now we can go through the evolution of computers. A first-generation computer used vacuum tubes and was a huge machine with very high power consumption. It was a processor-centric machine. Its speed barely reached 100 commands per second. And only a few prototypes existed of them. A second-generation computer used semiconductors in comparison with first-generation computer. It became storage-centric and its speed was increased, which was measured in microseconds. However, its size and power consumption were decreased. Those machines could be programmed by assembly and they were able for batch processing. A third-generation computer used integrated circuits and operational memory. This generation of computers had big storage capacity. Instead of punch cards, mouse and keyboard were used for input. They used an operating system for better source management and used the concept of time sharing and multiple programming. These computers reduced the computational time from microseconds to nanoseconds. The fourth generation technology is based on microprocessors. A microprocessor is used any logical and arithmetic function to be performed in any program. Graphical user interface technology was exploited to offer more comfort to users. All types of high-level language can be used in this type of computers, and first computer network was developed during this time. The fifth generation is based on artificial intelligence. The aim of the fifth generation is to make a device which could respond to natural language input and are capable of learning and self-organization. This generation is based on ultra-large-scale integration technology, resulting in the production of microprocessor chips having 10 million electronic components. Finally, just to mention a few programming languages and operation systems. You have probably heard about the DOS, the Windows, the Mac OS, which is based on Unix, then the Linux, real-time operation system, Android, iOS, Harmony OS, Wear OS, and others. Let's see a few programming languages. The Ada, Basic, C, C++, C#, COBOL, Fortran, Java, Pascal, Python, PHP, Ruby, and a lot more. And we can conclude that ICT is one of the fastest growing fields in the world. Thank you for your attention.